We want to test equations for symmetry about the axes and the origin. We have three different types of symmetry we discuss in algebra. One is symmetric about the x-axis, and what that means is that the equation is a mirror image of itself this way. And as you can see, that is not a function. That's not ever a function, which doesn't mean that it's not some sort of relation that is of interest to us. If we have symmetry about the y-axis, what that means is that the image is symmetric horizontally. And that can be a function, but doesn't have to be. And then we have symmetry about the origin. And what that means is that if I take the image and I rotate it 180 degrees, so actually flip the sheet of paper 180 degrees, I have the same image that I started with. And again, that can be a function, but doesn't have to be. And here are the rules for how I determine these. I have symmetry about the x-axis if and only if. That double-sided arrow means if and only if. When I substitute negative y, right, so I substitute negative y, it doesn't change the equation. I end up with the same equation. Right? Put negative y in the equation and positive y is just as good. I have y-axis symmetry if I put in negative x for x, and I get the same equation. Right? So I'm going to put in negative x, and I get the same equation. So I'll have the same values this way. And then I have symmetry about the origin only if I substitute in negative x, negative y, and I get the same equation. That is, if I put in negative x, negative y, then positive x, positive y is also on the graph. So, for the first equation I'm given, I have 3, and I'm going to substitute negative y. So 3x squared plus 24 times negative y squared is equal to 28, and that's the same thing as 3x squared plus 24y squared is equal to 28. So I do have x-axis symmetry. And if I put negative x in, I get 3, well, I guess I can stay up here. Okay, 3 times negative x squared plus 24 times y squared. I don't need those parentheses. Let me see. Y squared is equal to 28. And that's the same thing as 3x squared plus 24y squared is equal to 28. And I already substituted both negative x and negative y, and I got the same equation. So I'm good here. That works. Okay, for the next one, I'm given negative x is equal to y cubed. And then I'm just going to slide down here. So if I substitute in negative y here, I get negative x is equal to negative y cubed. And that is negative x is equal to negative y cubed. And that's x is equal to y cubed. That is not the same function. So I do not have x-axis symmetry. Here I am going to substitute in negative x. So negative of negative x is equal to y cubed. And that gives me x is equal to y cubed. And that is not the same function. So I do not have y-axis symmetry. And here I'm going to substitute in negative x and negative y. And that gives me x is equal to negative y cubed, or in other words, negative x is equal to y cubed. And that is the same, so I do have symmetry about the origin. Oops, symmetry about the origin. Okay, we have not talked about how to graph this, and we don't in college algebra. We do learn that in pre-calculus, but I want to show you what that graph actually looks like. This is the graph of the first equation. 3x squared plus 24y squared is equal to 28, and it's an ellipse that opens this way, or that is oriented that way, as opposed to being taller than it is wide. And then The second one that we're given is a cube root function turned upside down. If I solve this for y, I get y is equal to negative cube root of x. So the second one is a function. The first one is not.